Okay, so today we're going to do section 1.2. Today we will be solving multi-step equations. This is going to be the next page in your notebook. Remember, you should have that loose vocabulary page. Still, we will not be adding to it today, but when I come back tomorrow, we'll be pasting that into the blank page that you have left in your notebook. So just make sure you hold on to that. The essential question for 1.2 is what processes are used when solving a multi-step equation? And just as a reminder, I will not be making pauses throughout the video. So if you need to pause the video so that you can catch up with writing, please make sure you let your substitute teacher know. So with my Cornell notes, the first thing we're going to do is put some steps in here. Steps to solving a multi-step equation. The first step is that you are going to clear any decimals or fractions, and I'm going to show you how to do that in one of our examples. If that step does not apply, you move on to step 2, which is to distribute and or combine like terms. So sometimes you will not have any distributing, you will just have like terms. Sometimes you will have distributing, but you won't need to combine like terms, and sometimes you'll have to do both. Very last thing you will do is to use inverse operations to solve for the variables. And the biggest reminder that you must do, and I would probably highlight this in your notebook, is that whatever you do to one side, you must do to the other. So if you add 3 on the left side, you have to add 3 to the right side of the equal sign. And then let's get into our first example. So example 1 is 5 equals 5m minus 23 plus 2m. These equations differ from what we did yesterday. Your instructions are going to be to solve for the variable. Yesterday, your instructions were to simplify because there was no equal sign. So now that we have an equal sign, you will be asked to solve. So our first step says to clear any decimals or fractions. In this example, I don't see any decimals or fractions, so we are going to skip that step and do distribute and or combine like terms. I also don't see any distributive property, but I do see a 5m plus a 2m, so we can combine like terms there. So I rewrite everything else exactly the way it is in the problem. 5 equals 5m plus 2m gives me 7m minus 23. The next step says to use inverse operations to solve for the variables. So that means I need to get my variable onto its own side. So if you guys notice, 7m is on the right, so it's going to stay there. But I have a minus 23. So the opposite, or the inverse, of minus 23 is to add 23. So I add 23 to the right, which means I need to also add 23 to the left. The reason that I do this is because negative 23 plus 23 gives me 0. So they cancel each other out, which is the whole point. On the left, and I'm going to move my work over to the right. Let me draw an arrow because I ran out of room. You can just keep going down. 5 plus 23 gives me 28 equals 7m. And this 7m is 7 times n. So to get rid of multiplication, I divide both sides by 7. The reason we do this is that 7 divided by 7 gives me 1. So the 7's end up reducing to 1. 8 divided by 7 gives me 4 equals 1m. So I solved for m. We can check our answer by taking 4 and substituting it back into the original equation where we saw m. So I will have you guys do that on your own. For right now, we're going to move on to the next problem. Example 2 is a word problem. Martha spent $67 shopping with her niece and nephew. Her niece bought $4 worth of candy and 1 shirt. Her nephew bought 2 shirts. And now the question is to find the cost of 1 shirt. So we're going to need to do what we call identify a variable. So I would like you to copy the problem into your notes. So you might want to pause the video so you can write it down. So let's identify a variable for the shirt. I'm just going to call the cost of 1 shirt X. Whenever you are identifying a variable, you need to always say what it stands for. So X equals the cost of 1 shirt. And now we're going to write an equation for all of this. So we need to write an expression that represents the niece, and then we need to represent an expression that represents the nephew. So I'm going to write an expression that represents the niece, and when I add that to how much the nephew spent, it all came out to $67. So the niece bought $4 worth of candy and 1 shirt. So the niece is going to be 4 plus X, the cost of 1 shirt. Plus the nephew. The nephew only bought 2 shirts. So that's going to be 2X. And that should all come out to equal $67. So following our steps, we don't have any decimals or fractions in this problem. And we also don't have distributive property, because even though 4 plus x is in parentheses, it's just being added to the 2x. So there's no multiplication here. So we can go straight into combining like terms. I see an x and a 2x. So that's going to give me 4 plus 3x equals 67. And I will need to get that 3x by itself. So I'm going to subtract 4 from both sides. 4 minus 4 gives me 0, so those cancel. I'm going to move my work over. So on the left, I have 3x equals 67 minus 4 gives me 63. And then to get x by itself, 3 times x, the inverse of that is division. So I'm going to divide both sides by 3. Because 3 divided by 3 is 1. So I have a 1x equals, 3 goes into 63 21 times. And this is in dollars. So the cost of 1 shirt is $21. Example 3. Negative 8 times 2x minus 1 equals 36. I still don't see any decimals or fractions, so we're going to go on to step 2. And in this problem, there is distribution because I have a negative 8 times 2x minus 1. So I distribute the negative 8 to both sides. And I multiply negative 8 times 2x minus, remember I don't like two negatives next to each other, so I put it in parentheses, negative 8 times 1 equals 36. Let's do that multiplication. Negative 8 times 2x gives me negative 16x minus negative 8 times 1 is negative 8 equals 36. So I have a negative times a negative, which makes it a positive. And I need to get that x by itself. So I'm going to subtract 8 from both sides. 8 minus 8 gives me 0, so those cancel. And once again, I'm going to move my work over. So on the left, I have negative 16x equals 36 minus 8 gives me 28. And then on the left, I have negative 16 times x equals 28. So to get rid of that negative 16 times x, I divide both sides by negative 16 because we do inverse operations. Negative 16 divided by negative 16 reduces to 1. So on the left-hand side, I have just an x left over. Equals. On the right-hand side, I have a fraction, so I need to reduce that. Let's look at 28 and negative 16. A number that goes into both of those is 4. So if I divide the top and the bottom and reduce by 4, that gives me negative on the outside 7 over 4. It is okay in higher math to leave your numbers as an improper fraction. So we can certainly leave our answer as negative 7 over 4. We could also rewrite this as a mixed number. So negative 4 goes into 7 once with a remainder of 3 over 4. So we could also rewrite this as negative 1 3/4. Or we can use this as a decimal, negative 1.75. You can use any of these three answers. They are all correct. You do not have to put all of them. So let's look at our second to last example, one that actually has a fraction. So example 4. I have 3 times x divided by 4 minus x divided by 3 equals 10. So with anytime we have a fraction, we want to look at our denominators and find what the common multiple that goes into both 4 and 3. So we're looking for a number that both 3 and 4 can go into so that we can reduce. I notice that 4 goes into the number 12 and 3 also goes into the number 12. So what I'm going to do is multiply both sides, because whatever I do to one side, I have to do to the other, by 12. And then watch what happens. I can use the distributive property on the left. So that's going to be 12 times 3x over 4 minus 12 times x over 3 equals 12 times 10. Twelve times 3x over 4. That's the same as 12 over 1. 12 times 3x gives me 36x. 1 times 4 gives me 4. Minus 12 over 1. 12 times x is 12x. Over 1 times 3 is 3. Equals 120. And then we actually can reduce these things. 4 goes into 36 9 times. So this actually reduces to 9x. Minus 12 divided by 3 gives me 4x. Equals 120. So now we're dealing with just whole numbers here. So let me move my work over. Let's combine like terms. So we just did step 1, which is to clear decimals and fractions. So now we can combine like terms. 9x minus 4x gives me 5x equals 120. And then the last step is to divide both sides by 5. So I get x equals 24. Our very last problem has decimals in it. Example 5, 3.5 minus 0.02x equals 1.24. So what we want to do is we need to find a number that will move the decimals over so that we have all whole numbers. On this 3.5, I just need to multiply or move the decimal over 1. So that would be the same as multiplying by 10. However, on this 0.02x, I need it moved over 2 spaces. So that's the same as multiplying by 100. So I'm going to multiply both the left and the right hand sides by 100. I can use the distributive property on the left. So that gives me 100 times 3.5 minus 100 times 0.02x equals 100 times 1.24. Multiplying by 100 moves my decimal over that many spaces. So the decimal moves over 2 spaces here. So 100 times 3.5 gives me 350 minus, the decimal moves over 2 spaces here. So that's just going to give me 2x equals, moving the decimal 2 here is 124. So I got rid of all the decimals. I used the distributive property. There's no combining like terms, so we're just going to get the x by itself. So I'm going to subtract 350. 350 minus 350 gives me 0, so that cancels. So here I have a minus 2x. I still have to leave the negative there. So this is negative 2x equals 124 minus 350 gives me negative 226. And then the very last thing I need to do is divide both sides by negative 2, because this is a negative 2 times x. Negative 2 divided by negative 2 cancel or reduces. And I have just an x on the left equals. A negative divided by a negative gives me a positive 113. So those are multi-step equations. You do have homework from the textbook again, page 19. Your homework that you did last night, I will collect it tomorrow or on Thursday when I am back. So just hold on to that assignment as well. On Thursday, we will correct last night's homework. We will correct tonight's homework, and then you will turn both of those in. Still, please do them on separate sheets of paper, and make sure you use your notes to help you. You guys can work together, and I will see you all on Thursday.